Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, Senior 3 Chemistry class. You're most welcome for today's lesson. As always, I'm Teacher Scovia, your chemistry teacher. So I think everybody is ready with a pen, a book, and ready to start for today's lesson. Isn't it? Everybody get a book, get a pen, and be ready to start with today's lesson. So today we are continuing with our Unit 2 that we had started in the previous lesson. Unit 2, which is nitrogen and its inorganic compounds, right? So you remember we had started this unit. We had talked a lot on this unit. We had discussed on nitrogen. We had looked at the preparation and isolation of nitrogen. Today, we are looking at lesson 3, which is preparation, properties, and uses of nitrogen compounds. Specifically, we are dealing with nitrogen dioxide, right? So you remember we had completed looking at nitrogen, its preparation, isolation in industry, and whatever. Today, we are looking at the inorganic compounds of nitrogen, putting emphasis on nitrogen dioxide, right? So what is the objective of today's lesson? At the end of this lesson, I expect every learner to be able to describe the laboratory preparation of nitrogen dioxide, to describe the properties of nitrogen dioxide, and to tell or to state the uses of nitrogen dioxide. All right? So, at the end of this lesson, I want everybody to be attentive such that when we finish this lesson, you can tell or you can describe laboratory preparation of nitrogen dioxide, properties of nitrogen dioxide, and uses of nitrogen dioxide. All right? I think you're very attentive and you're ready to start with our lesson today. Let's go on and see. So, we start by looking at the laboratory preparation of nitrogen dioxide. The laboratory preparation of nitrogen dioxide. So look at the diagram on the screen or on the slides. So we are going to look at laboratory preparation of nitrogen in two ways, or two methods. There are many ways of preparing nitrogen dioxide. We are putting emphasis on two major ways of preparing nitrogen dioxide. One is reacting copper solid, or copper tannings with nitric acid, all right? So look at this diagram here. In the previous lessons, when we were studying about preparation of substances in the laboratory, there are around 4 things I always emphasize. There are around 4 things that I always tell you to put into consideration. One, you should know the diagram of preparation, to label it, to draw it, and to label it. All right? Another thing is to know how to write the equation of the reactions. So that is the diagram. The diagram, you see, you have here concentrated nitric acid, right? Being powered into copper tannings. This is the round bottom of the flask. We use the thistle funnel. This is a delivery tube. So this is a gas jar where nitrogen dioxide is collected, all right? So here, when we look at the diagram, you need to know how to draw it properly and to label it and to write the equation of reaction. So we have copper solids or copper tannings, the equation of reaction, all right? Copper solids plus, all right, nitric acid. All right? This is a liquid. You get copper nitrate, aqueous, plus water and nitrogen dioxide, plus water plus nitrogen dioxide gas. All right? So you need to balance the equation. I always emphasize this. When we are writing the equation, there are three things you need to put into consideration. One, you need to know how to write the symbols properly. All right? You need to know how to balance the equation, and you need to know to put the states of matter. If you write an equation without states, if you write an equation without writing properly the symbols, if you write an equation without balancing it, that is not a good equation in chemistry. All right? So we are balancing it. We have 2. So you need to put 4 here. All right? We need to put 2 here. And we need to put 2 here. If you balance this, you find it's 1 copper, have 4 hydrogen. These are 4 hydrogen. Have 4 nitrogen. You multiply this. These are 2 nitrogen plus these 2 nitrogen, 4 nitrogens. You multiply this with this, 12 of oxygen. These are 6 oxygen plus 2 oxygen. Those are 8 oxygen plus 4 oxygen. Those are 12 oxygen, which equals 12 oxygen. So it is balanced with states. So whenever I told you, whenever you see L on an acid, you find there is L. It means concentrated. If it was not concentrated nitric acid, we find HU. That is aqueous. All right? Good. So this is the equation of reaction. So in the laboratory, when we are preparing nitrogen dioxide, we use copper tannings. We put it into a round bottom flask. We add the concentrated nitric acid. All right? It gives off, it forms a green solution of copper nitrate. All right? This is green in color. Copper 2 nitrate is green in color. All right? And a red-brown gas. Red-brown gas of nitrogen dioxide. All right? So this is the equation of reaction in the formation of nitrogen dioxide. All right? So you remember another thing I emphasized here on this preparation of gases and the other substances in the laboratory. We talked of the collection method, or method of correction, in other words. So from the diagram there, students, look on the slide and tell me, you remember the other time when we discussed about this on preparation of other substances, I emphasized on the point where you need to know the collection, the method of collection. So when you look at this delivery tube in the gas jar, what do you think which type of method is this? Which type of method is this? Who can try this? Yes. Yeah. Since the delivery tube is pointing downwards, this is downward delivery. Downward, downward, downward delivery. All right? Downward delivery. Why? Always pose a question. Why do we say it is downward delivery? Oh, in other words, those gases which are collected by downward delivery, which property do they possess? Which property do they have? All right? Who can try that? Because we have been mentioning this. Yeah, it's less dense than air. Right? When we are talking about methods of correction, when we are talking about methods of correction, when something is corrected by downward delivery, it means it's more dense than air. More dense than air. So nitrogen dioxide, for this case, is more dense than air. That's why it's collected by downward, more dense than air. Therefore, collected by downward delivery. If it is less dense than air, then you find it collected by upward delivery. When it is insoluble in water, you find it is collected collected over water. So you need to know those things. Whenever we are studying on preparation of substances in the laboratory, these are the major things you need to look at or to put into consideration. One, the reagents used, that is copper, tannins, and nitric acid. The equation is here. The collection, downward delivery. Why? Because nitrogen dioxide is more dense than air. All right? I think that is clear to everybody. So whenever you react copper tanning with nitric acid, a green solution of copper 2 nitrate is formed, and a liberation of a red-brown gas, which is nitrogen dioxide, is seen or observed. That is it. Think you have understood that, all right? Good. So another way of preparing nitrogen dioxide in the lab, we can prepare nitrogen dioxide also by heating lead-2 nitrate. All right? When you heat lead-2 nitrate, as the equation is there on the board, on the screen or on the slide, when we heat lead-2 nitrate, we form lead oxide, nitrogen dioxide, and oxygen gas. So there are two gases that are formed there. That is nitrogen dioxide and oxygen gas. All right? So this gas is cooled by using ice and salt. So as you cool it, for oxygen is just given off or is collected over water because oxygen is insoluble in water. So it is collected over water. So this nitrogen dioxide is cooled by ice and salt. When you cool it, you form dinitrogen tetroxide. So when you form dinitrogen tetroxide, as in the equation you see below there, this one, when you increase temperature, when you raise some temperature, it gives out, or it decomposes to give nitrogen dioxide, or it dissociates into nitrogen dioxide. All right? So the way how these two gases, see, when you hear, I emphasize on this, when you decompose lead-2 nitrogen, when you decompose lead nitrate, you give lead oxide, nitrogen dioxide, and oxygen gas. You see, there are two gases that have been formed, all right? So how to separate them? When you cool, or you apply ice and salt to cool the gas, for oxygen is just given off or is collected over water because it is insoluble in water. But this nitrogen dioxide, for this, when you cool it, it forms dinitrogen tetroxide. All right? So when it forms it, as the equation here, when it forms dinitrogen tetroxide here, this one can easily dissociate into nitrogen when you just raise the temperature, into nitrogen dioxide. So those are two ways on how you can prepare nitrogen dioxide in the laboratory. All right? Good. So we can continue and look at the physical properties now. The physical properties of nitrogen dioxide. One, as we have had earlier mentioned, it is a red-brown gas. So nitrogen dioxide is a red-brown gas. When you're doing a practical and you see that the gas given off is a red-brown gas, you expect to be a nitrogen dioxide gas. Nitrogen dioxide gas has irritating pungent smell. That's why we say it is even very dangerous, or it's a kind of poisonous to smell in a quantity of nitrogen dioxide. All right? It is soluble in water, forming an acidic solution. So when you dissolve nitrogen dioxide in water, you form acidic solution. That is a that is nitric acid and nitrous acid. So it is soluble in water, in other words, as a physical state. So it is 1.5 times denser than air. That's why we said it is collected by downward delivery, because it is 1.5 times denser than air. It is easily liquefied on cooling. So the boiling point is 21 degrees Celsius. So those are some of the properties of nitrogen dioxide, the physical properties. Remember, when we talk of the properties, we expect the physical properties and we expect the chemical properties. So these are physical properties. So what are the chemical properties of nitrogen dioxide? So always I say, when we are talking about the chemical properties, we are talking about the reactions. How nitrogen dioxide reacts with other elements or compounds or substances, in other words. All right? So one, combustion. So nitrogen dioxide does not burn, does not support burning or combustion. That's why when you bring a growing spirit, a burning growing spirit, it turns it off. So when you introduce a burning spirit into nitrogen gas, into a test tube, a gas jar containing nitrogen dioxide, the burning spirit turns off or goes off. So reaction with water. As I said earlier, nitrogen dioxide reacts with water or dissolves in water to form nitric acid and nitrous acid. That's the equation you see on the screen here. When you react nitrogen dioxide with water, you get nitric acid and nitrous acid. There is 3 here, there is 2 here. That's the difference. Nitric acid and nitrous acid. All right? So you should be very careful with this. Another thing with you can add here, when we talk of nitrogen dioxide, since it is acidic gas, one of the acidic gas, it turns a wet blue litmus paper red. You remember the properties of acids. Acids turn blue wet litmus paper red. So for this case, because nitrogen dioxide gas is acidic gas, it turns a blue litmus paper red. So you have a gas jar or you have a test tube containing or having in it nitrogen dioxide gas. Then you try to put in or to introduce in a wet blue litmus paper. Immediately it will turn into red. So that is a property that nitrogen dioxide gas is acidic gas. All right? Good. You remember the properties of acids and bases. Acids turn blue litmus paper red, bases turn red litmus paper blue. So nitrogen dioxide gas is acidic gas and turns a wet blue litmus paper red. So another factor or another chemical property of nitrogen dioxide is the effect on burning elements. Right? So burning magnesium will continue to burn in nitrogen dioxide, forming magnesium oxide and nitrogen gas, as the equation you see here. When magnesium is burning, it will continue to burn in nitrogen dioxide to form magnesium oxide and nitrogen gas. Why do you think that when magnesium is burning, will continue to burn in nitrogen? We said when it is a burning spirit introduced in nitrogen dioxide, it turns off. But for case of magnesium, we are saying when magnesium is burning, it will continue to burn in nitrogen dioxide. Why do you think so? This is because the heat from burning magnesium decomposes this gas into its constituent, that is nitrogen and oxygen. And you know oxygen supports burning. So since there is production of this oxygen will support the continuation of burning magnesium, or magnesium to continue burning. So it is this oxygen that is produced in the process that will help the burning magnesium to continue burning. Right? Good. I think you understand that. So for the case of a burning spirit, when introduced in nitrogen dioxide, it is turned off. But for magnesium, burning magnesium, it will continue burning because in the process, oxygen will be produced, which will facilitate or will boost the continuation of burning of magnesium in nitrogen dioxide. Right? Good. So reaction with sodium hydroxide solution. So when we react sodium hydroxide, right, with nitrogen dioxide, we get sodium nitrate, sodium nitrite, and water. So two salts are formed. These are salts, by the way. Sodium nitrate and sodium nitrite. These are salts that are formed. So whenever you react sodium hydroxide with nitrogen dioxide, we expect to get two salts and water. That is sodium nitrate and sodium nitrite. 2, 3. Nitrate, nitrite. Plus some water. All right? Good. So we can continue on the uses of nitrogen dioxide. So where do we need nitrogen dioxide in everyday life? Where do we need to use nitrogen dioxide? Why do we need to prepare nitrogen dioxide? Because if it was not of importance, we wouldn't bother to prepare it. So because it is very important in everyday life, so we need to prepare it. So what is its role? What's its importance? So one, nitrogen dioxide is used in the manufacture of nitric acid. Right? It's very important in manufacture of nitric acid in Oswald's process. This is a process that is used in the manufacture of nitric acid. So there we need nitrogen dioxide. Another thing, it is an intermediate in the formation of very dilute nitric acid during lightning. This acid is washed into the soil, thereby increasing the amount of nitrates in the soil. So nitrogen dioxide takes part in the formation of the soil fertility in a way that, since it is used in dilution of nitric acid during lightning, as it is washed away by soil erosion, it will increase the amount of nitrates in the soil. And you know, nitrates are very important, or is very important in fertility of the soil, or it is used by the plants. Right? Good. So these are some of the questions. So to remind of what you have covered. You need to know, I emphasized in the beginning that by the time we finish this lesson, you should be able to tell the preparation of nitrogen dioxide. So we have looked at the two methods of preparing nitrogen. That is reacting kappa tannins with nitric acid. Another method is heating or decomposing lead-2 nitrate. You need to know the physical properties of nitrogen dioxide. You need to know the chemical properties of nitrogen dioxide, and you need to tell the uses of nitrogen dioxide. All right? So these are some of the trial questions that you're going to do when you reach at home. And by the time you come back, we shall pass through them. So the first question is, it is among what we have been talking. The first question is, nitrogen dioxide dissolves in water to form two acids. We talked about that. So write the chemical equation for the reaction that takes place. You remember the two acids we talked of. So write the equation of reaction. Another thing is nitrogen dioxide neither burns nor supports burning. However, burning magnesium continues to burn in the presence of the gas. Explain why. If nitrogen dioxide does not support burning, no, now it burns. But we say burning magnesium will continue to burn in presence of nitrogen dioxide. Why do you think so? I've explained that. The last one is you give at least one use of nitrogen dioxide. All right? So thank you so much for your good attention. I think you have enjoyed the lesson, and you have been very attentive as I've been observing you. So let's meet in the next lesson when you have done all these questions that I've left behind, and we shall try to collect them together. Thank you so much. Next time, bye.